Okay, good afternoon. Thank you for joining my talk. It's called Innovation Without Asking Permission. I'm glad that so many of you are here. I heard there's a very good talk in the Agile room as well, so thank you for joining mine. So the talk is about the use of new technology and the fear of change in existing applications. My name is Bart Blommaerts. I'm a hands-on application architect. At the beginning of this year, as many of you know, I started my own company called BB Consulting. Before that, I used to work for Ordino. There's a lot of people here that I remember from the past, but there's also a surprising amount of new faces. Anyway, if you want to contact me, you can always reach me via my Twitter handle. If you have any questions, remarks, or anything, just go over there. That's enough of the introduction. It's very awkward. Let's get started. Who likes developing software? Awesome. Software development is awesome. I mean, we get to face new technology, new innovation all the time. And we all know that there's a constant change in our industry, in our landscape. A couple of years ago, everybody was doing server-side front ends. We're using frameworks like JSF or Wicked, and it was all rendered in the browser. And then we moved on to client-side. We had JavaScript, and everything was better. And now, apparently, the previous talk was about server-side in the front-end kind of things, micro. God knows what's happening. So micro front-ends, a lot of things are happening, and that's really interesting. We've seen the same movement in backend, where we used to build large monolithic applications, and we moved to microservices. Then we went on to build serverless computing, etc. So if you're passionate about software, you try to stay up to date. You visit conferences, you follow some people on Twitter, you read a lot of articles, and it's really great industry to be part of. So we're always looking at, oh, what's the next shiny thing? What's the new sports car? That's where, as an industry, it doesn't get boring. But if you go to a conference and then you come back home and you go work on your application at your customer, it's different, right? I have a question. Who here in the audience is working? Here, wants it? Okay. Is working on an application that started over a year ago? Okay, keep your hands up. Started over 2 years ago. Okay, by half of you. 5 years ago? 10 years ago? Okay, so there's still people who are working on older software, and that's good. Because legacy applications, they have proven that they have value. If you work on a greenfield application, it hasn't proven anything yet. So it's important that we keep working on legacy applications because they have value. However, this means that a lot of people are working with larger and older code bases. They're not working with microservices, they're not working with Spring Boot or Spring Boot 2, they're not working with Java 11. And wouldn't it be nice if we could combine those existing larger applications with new technology, with new frameworks, with new language features that are out there? And that's exactly what this talk is about. And I'd like to start with a quote I read on Twitter. It's about the colossal gap between solutions that we see at conferences and the solutions that people are actually working on. And that's okay, the colossal gap is okay. Conferences tend to aspire developers, they tend to be inspirational. People want to go home and say, oh, I've seen 10 new things, I want to do everything. And then you go do struts somewhere. But that's okay, I mean, but there's a gap, and I think it's possible to kind of fill that gap. The first part to do this is service decomposition. Now, just a warning, this is not a talk about microservices. There's plenty of talks that cover microservices. I assume that most of you have worked on microservices or at least have some knowledge about them. This is a talk about using microservices as a means to innovate in a legacy landscape. So it's not only about the fun stuff, it's actually about the hard stuff. You can still go to the Agile talk if you say, oh, I don't want to do this. Service decomposition means splitting up larger applications, larger monolithic applications into smaller parts. And these new smaller parts, they allow for innovation, they allow for the use of new technology. Of course, introducing new technology or experimenting as a means to bring a business solution. So there's in general 3 approaches to service decomposition. There's a split, where you just try to move parts from your legacy application somewhere else. There is strangle, which is about re-implementing a part of the application, and there's also extending, where you just don't build new features in the legacy application. Let's dive into these into detail. When we talk about splitting applications, we see that, well, often we see that applications are layered around technology. Classical applications have a model layer, a view layer, a presentation layer, or a controller layer, whatever you want to call it. Everybody who has been in our industry long enough has worked on these kind of applications. Splitting up on these technical boundaries doesn't make a lot of sense. It is very difficult because why would we create a persistent microservice? Everybody else that uses some kind of database would need to call the persistent microservice. We don't want to do that. So even especially with microservices, when we do these kind of calls over HTTP, will be very difficult at best and very likely impossible. However, what we want to do is use vertical functional boundaries for your applications. So if you have a legacy application that is organized in vertical layers, using this functionality as a differentiator, it will become a lot more easy. Because ideally, these vertical layers, they will have maybe their own data model, and then you can immediately start seeing, okay, these parts belong together. In practice, unfortunately, this is not something that we see very often in larger legacy applications. It is definitely something that we should be doing when we create new applications. The second part is the strangle pattern. It was actually made famous by Martin Fowler back in 2004, which is 14 years ago, so it's a very long time ago, but it's still very valid. And with strangling applications, we are going to look at what parts of the application that need to be refactored anyway. We can define a domain of change. I mean, why are we working on this application? Is it possible to extract that from the application? In my humble opinion, this is one of the more difficult parts to split up an application. So when we will be looking at the demo later, that's exactly what I will be doing. And I'm also going to talk about an anti-corruption layer more in detail in just a couple of slides. Now, when we look at strangling the application, the goal is to make the monolith smaller, but very often this also will mean that functionality gets moved somewhere else, and your monolithic application, it will require new tests. It will require changes in the code as well, before you can start strangling the application. And then last but not least, it is the extend approach, where you just implement new functionality in new microservices. Now, of course, to avoid coupling between your legacy application and your new application, we need to make sure that we look at loose coupling at solutions, that we don't tie the applications back up together, because in that case, we're just creating a distributed mess, and that's something that we definitely don't want to do. So the goal of extending the application is to prevent the monolith from growing. And when there's an interaction between the monolithic application and the new extended microservice, there will also be an anti-corruption layer in between those. So we just saw these three approaches. From the get-go, we don't need to pick one. Very likely in larger projects, you will be using all three of these. I will be focusing on the strangler pattern in the demo later, because I believe it's one of the more difficult approaches. But again, in practice, don't stick by one. I touched on the anti-corruption layer before. So what are these kind of anti-corruption layers? As the name implies, it is a technology layer. So when multiple components in the system need to communicate, they need some kind of translation between their domain models. If your legacy application has a very nicely defined domain model, we want to make sure that it uses its domain model. But our service, the new thing that we're building, it will very likely have a different domain model. It might be smaller, it should be smaller. And to make sure that everybody can talk his own language, can speak its own language, there can be a mapping in between those. There's also a very nice way to enforce loose coupling between different bounded contexts. What's also very interesting, if we look at the anti-corruption layer, we don't want, this is a technology layer, right? But we want to provide an API for that layer, because if you don't have an interface between the incoming and outgoing calls, then again, we're introducing new coupling. So unlike data, the anti-corruption layer deals with a different kind of data, and there's multiple ways of doing this. It's the shared repository, a data synchronized repository, and then finally the most mature form of loose coupling is event-driven synchronized repository. So let's look at these into detail. The first one is a shared repository. So if you have ever worked with a larger, older application, you will see that it has some kind of database, and everybody in the application can consume the database. The layering in the monolith is not important. It's not relevant to what I'm trying to explain, but everybody is just one query away from getting new data. So it actually makes a lot of sense if there's only one application that it uses this database. But you want to innovate. You want to do something new. Maybe your customer wants to do new things. So you introduce new microservices. Maybe you're using new technology in those microservices, and they have their own custom-tailored domain. So each microservice has its domain, and you don't want to share that, or you don't want to leak that domain to the monolith or to the other microservice. So you need some kind of anti-corruption layer. And in here, in the anti-corruption layer, you can see that domain objects from the monolith will get translated to the microservices via a very nice API. And they share this database. This is the first approach. Obviously, this is not the best approach that we can choose, because we actually introduce more complexity. If one day something needs to change in the database, so maybe you need to add a new field to the database table, we actually made things worse, because now we have to deal with the change in the monolith application, in the anti-corruption layer, and maybe even in the microservice layer. So we need to do better. And the second way of doing this is using a data synchronized repository. So we still have the anti-corruption layer in between, but the anti-corruption layer will populate data in a database that is specific for that microservice. So this is the old polyglot persistence paradigm, where each microservice uses its domain model to consume a database that it understands. And the anti-corruption layer will take care of the translation in between. This, of course, can also be directional. If the monolithic application needs information from the newer microservices, you can also use the ACL, the anti-corruption layer, to populate the new database. Ideally, this can be an asynchronous process, because if we need to wait, for example, in the microservices before the translation is done via this database, then again we have a shared database that's going to cause a lot of problems. And then finally, as a last step to increase the microservice maturity, we can use an event-driven synchronized repository. Here we're introducing a messaging system, a queuing system for your monolith, and it will capture all the events that others might potentially be interested in. A very nice quote that says, "Don't wait to be asked for data, just publish it up front." It is possible that some data will not be consumed, and that's perfectly fine as well. The ACL, the anti-corruption layer, will be a subscriber to the messaging system, so not to the database, because we're trying to avoid that coupling. And it will do the translation and in turn publish the new events in the new domain model to a queue, specifically to a messaging system, specifically for that microservice. From a data point of view, and I will go more in depth about this, I've been talking about events, and it's important that the event carries all the data that it needs. So what is an event? Maybe I should focus on that as first. An event is something typically that has happened in the past. And events is probably, in my opinion, the best way to ensure full encapsulation and loose coupling. Don't take this as a very romantic solution for every problem, because you will still have coupling, but the coupling will be in the events. But the coupling will not be in application code, so there's a big difference. So an event is something that typically happened in the past, and it contains three kinds of data. So there's the data that it owns. So imagine that the publisher publishes some kind of event, then that publisher is master of that data. So that's the data that the event owns. There's also data that it needs. So maybe your publisher needs to query information from another service and also put that in the event to make sure that the event has all the information that it needs. And then finally, there's reference data. An example that I always give is if you are booking a holiday and you need reference temperatures of the months at that particular location, you want to also package that in the event and then ship it to your messaging system. In legacy applications, you will see that if an event or if a method doesn't have all the data that it needs to do its job, it will just be one query away, and you're actually not thinking about your domain model. You're just passing some data to a method, and then you see, oh, I need more data, so just I query. That's only one database call away. That's absolutely not true when you're trying to build a loosely coupled system. Events represent business capabilities, so an event is not a mapping of a table in a database. Ideally, you will be able to talk about events with your business stakeholders and help and make sure that they can help you in creating what the event should look like. There will be a lot of more detail about that during the demo. Bounded contexts. They depict the boundaries of a certain microservice. They will define where a microservice starts and where it ends. It was made popular from domain-driven design. I think that a lot of you have some knowledge of domain-driven design. I'm not entirely sure if many of you have knowledge of what's called DDD Light. It's a term coined by Greg Young. If you ever want to do a project and use domain-driven design, watch the movie. I linked it in the end. It's one of the reference people regarding domain-driven design. Watch the movie once, then decide not to do it and watch it again. It is the most valuable resource on domain-driven design that I've ever seen, because all of the caveats that come with domain-driven design are explained extremely well by Greg Young, who's the reference. It's about anti-patterns that cause DDD projects to fail. You'll see the link at the end. Now there's a lot of theoretical talk about bounded context, and there have been written entire books, so I don't want to do the theoretical approach. I want to use a real life case. It's about the postal services in Belgium. Some of you will be kind of familiar with the postal services in Belgium. It's loosely based on a project that I've done some time ago. Not entirely. So that's my phone. Very brief 5-minute explanation of what it does. By law, in Belgium, the bpost, the mail delivery guys, they are obliged to pass by every house at least once a day. They have a contract with the government and they need to do that, even if there's nothing useful that they can do there. And if we look at the evolution of mail, it has changed a lot over the years. In the past, it was post, and it turned out to be gele briefkaarten, and then there were packages. And nowadays, you can just call bpost and have them decode, have them install your Belgacom decoder. Funny story: in Denmark, you can actually call the postal office and have them mow your lawn. So there's a lot of changes in there as well. Some of the goods get delivered by motorbike. Some are too large and they need some kind of van. So there's also a lot of possible delivery ways as well. And the postal service, they have offices in a lot of the municipalities in Belgium. So every city has its postal office, and they will try to bring the goods to those postal offices closest to your house to make sure that they don't need to travel all around the country. Then some services, they have time constraints. For example, the newspaper needs to be delivered before, I think, 9 o'clock in the morning. And you can buy extra services. So, for example, you can say, okay, I want you to bundle my mail and only come to my house once a day or once a week. It's something that has been done a lot by enterprises, by organizations. And then the typical Belgian example, and this is the first time I actually give this presentation in Belgium, but you will all understand, houses are built, new houses are built as well. So the geographical data of Belgium is changing all of the time. And we have so many governments that a lot of the time people don't know where they're living. The postal offices doesn't really necessarily know if your house is already inhabited or not, because Belgium. So you can imagine that calculating the optimal route to go from one place to the next by your delivery person, that it's a difficult calculation. It's something that also changes very often. And it might be a very nice candidate to extract from a monolithic application and to maybe use a better technology that's specialized in calculation algorithms. It was actually a proposal I did, but that was never implemented. Among other things that were never implemented. So our goal is to figure out where the microservices will begin and where it will end. So we need to retrieve this information from the legacy monolithic application. So as I said earlier, we need to focus on business capability, not on technology layer. And we need a deep understanding of the monolithic application. We need to have an obsession with business. We need to know what these people want to do. So we will try to identify the bounded context. It's very easy for me to say, okay, this is the bounded context, but it's more difficult if you really want to identify it for new projects. So we start with the domain, and the domain is very large. Typically, it's mail delivery. I mean, that's what's going on. most legacy applications will have multiple domains, but we don't need to start too small. You can always refactor afterwards. And a domain will have subdomains, like mail delivery needs an optimal route calculation. It will need the geographical division of Belgium, etc., etc. These subdomains typically map with a bounded context. So there's a couple of tips on how you can come up with the bounded context, and you can also use this for greenfield developments. And this is actually looking at the data model. And data model design is not something that should be left to coincidence. A lot of people these days are saying, oh, we're doing microservices. Every microservice has its own small database, so I don't really need to think about the way my data is structured, and that's absolutely wrong, and you will fail if you think in it that way. These days, data model design is just as important as it was when we had one very large database. Now, how are we going to do this? And I have 3 tips to determine your bounded context. And that's the first one, most important one, is talk to your business stakeholders. In general, your business knows your business. In general. Now, what generally works well, because it's possible that you need to help your business with this. What I've seen being successful is when you make a formal list of your potential subdomains, of your potential bounded context, and then talk about this list with your business stakeholders. Look at reasons why things might belong together, and just discuss about it. It's something iterative that you do. And making this list explicit will always yield new insights, because business will think about things that it wasn't thinking about in the past. Maybe if you know the domain pretty well, you know that change will come in new manners, because maybe you have seen that Amazon does drone delivery right now. Maybe bpost doesn't know that there's drone delivery. Maybe they don't want to invest in it, but you can talk about it. Now, if you're just starting with one microservices from your monolith, then you can always use this list also as your documentation. Just put it in Swagger or in Spring REST or whatever that you're using, then you already have a head start for your documentation as well. Now you can even go further, and this is where the lines get a little blurry, but you can validate this list as well with your business stakeholders by mapping it on use cases. If you're starting from scratch, it might be useful if you try to map the subdomain with a certain use case. After a while, in general, it's more reasonable to define your use cases during a sprint planning when you actually intend to implement something, and when you have thought about, okay, I need my definition of ready before I can start implementing it. So an example use case is the mail delivery by bike in a rural area. It's different from in a city. If your business stakeholders have no clue what they're doing, and you can't find another project, look at the data. Most systems have some kind of database. If you're lucky, you will also have documentation of this database, and it will even be up to date. I've never seen that. So chances are that you will need to look at your database, at your tables, and refactor a lot of business logic from what's happening in there. The data is always right, because that's what's being consumed. Even if it's incorrect, then it's still right. If you have duplicate users, then you still have users, which we're fixing. Now, since our microservice will also have its own database, looking at the data and documenting it is also a very good starting point to come up with a database for your new microservice with some kind of, for example, an entity relationship diagram or whatever format that you like. Now, looking at data is the second best thing that you can do if your business stakeholders are not available. Maybe they're in a different country, maybe they're not very cooperative. All possible. Now, when there are no domain experts, no business people available, and your database is an incomprehensible mess, then you can also look at the code. Because not just looking at the code, but also looking at the history of the code. If you have a version control system, which you should have, then you can easily create scripts and see, for example, which files are always committed together. If 2 files are always committed together, then they're likely related, then there will likely be part of the same bounded context. There is some tooling around this area, but in general, if you, for example, use Git, then you can create fairly easy scripts. You can fairly easily create scripts to get this information as well and say, okay, for example, these are always committed together, and that makes a lot of sense, so we're all going to put them in the bounded context. Now, since we're creating microservices, since we're creating distributed systems, we will be looking at integration patterns. There is a huge amount of integration patterns, like anti-corruption layer, for example, is an integration pattern. There is shared kernel, which some of you really like, I know that. There's customer supplier, there is open host service. There's a lot of potential integration patterns. And if you're building microservices, then you should be investigating these as well. It's not the most popular topic because the entry to getting to know this can be fairly complex. One book that I always quote is the Enterprise Integration Pattern book by Gregor Hope from Google and John something, I forgot his name. You can get it on an ebook, and then you can use the index just to jump to the different places, and it will explain all about messaging systems, about single queues or maybe data type queues. All of those things are super well explained in the book. And it's still up to date because it's still updating the website with new examples. So if you want an example of a certain pattern and you're using Kafka, then those are available as well. Really, really good book. I urge everybody who's working with microservices to read it. As an example, from the postal services, we are going to extract the round calculation from the monolithic application. And you see there's a lot of other components that might be suitable for extraction later. And we're going to publish events on a messaging system. And the round calculation will listen to these events and then maybe persist some in a database or do the actual calculation. There's just an important disclaimer because this once came up. Right now, there's only one domain, so the entire gray box is the domain. It is likely that there will be, as I said earlier, multiple domains in your application. And if that's the case, it's also very useful to come up with some kind of context map or something where you can map these domains together to make sure that you're not duplicating bounded context. If a lot of parts of the application use a certain bounded context, maybe create a larger microservice and have both of these domains use that same bounded context. Okay, demo. Oh, that's not a demo. That's also not a demo. Go IntelliJ. So, it is still preparing my workspace. I'm going to start with the legacy application. That's this one. I don't need that next one. Is this readable? Should be readable, right? If you're coming across a calculation algorithm in a large monolithic system, then it will always look like this. There is initializing some stuff, and then there's getting some stuff because, okay, my events that I pass don't have everything that I need, or the postal information that I pass to the method. Then I will do some calculation. I will persist it because somebody else needs the information. And in general, those kind of things, when not being well designed or when they've been used a lot of the time, they look like this. They look like a mess. We know that this is the part of the application that we want to refactor to a microservice. So let's have a look how we could do that. This obviously doesn't do anything. And I'll change. Okay, I'll explain it. Still readable? Okay. So the existing calculation algorithm, we want to extract it from the microservice. As you can see, we haven't removed it yet. I'll talk about why we haven't removed it yet later. But here we say, okay, we want to have a new event. It's called the rounds requested event because that's what we want to do. We want to get rounds from the system, so I'm requesting them. And we're creating some kind of a hash map that has data in it. Just for the sake of the demo, I'll change it that you know that I'm not cheating. Meanwhile, I'll also start my queue because I didn't do that. So for the demo, I'm just using RabbitMQ because it's fast and easy. In this code, you will see that I have an event. And the event in itself doesn't contain a lot of information, but it extends this abstract class. Events generally are immutable, which means that this class doesn't have any setters. It does its gathers, and if you want to instantiate it, you need to go via the constructor, and it will also stream over the hash map to make sure that you have a deep copy. What's interesting about this approach is that you can have a fairly generic event class, and that all of the events that you're using extend from this event class, and that they don't need a lot. It's their own implementation. What you could do, and that's something that if I remember correctly, Kenny Bastiani advocates, is that you also have a generic, and that you put the generic of the class that you're turning into an event also in the event. So for example, events where you have a T, and then you create an implementation of this class, and then you also set the T in the constructor to make sure that you have the event, the actual POJO where you started with as well. But that's not to be used as an event. That's just for documentation, for debugging, etc. What we are using in the demo for the events is Avro, Apache Avro. It looks like this. This will say that we have an event UID, we have a name of the event, and then we have this mop. So this maps to the abstract event class that I created earlier. And Avro will take care of a lot of the marshalling and the unmarshalling for us. It will put it in a very concise size so that it can easily be transmitted to a messaging system. Avro events. It will generate, if you use the correct Maven plugin, this class. You get a type safe way of doing these things. All the eventing in itself, the sending messages to the queue is very simple. You will just you have a method that publishes an event. You have a message of type Avro event, and then you just send it to a queue. Everybody who has ever used Spring Cloud or Spring Cloud Stream knows how this works. What is important that you set the correct header, because we will be unmarshalling the object later. And then you just will create your, based on the content of your event, you will map it to an Avro event, and then just publish it. I have a test that does this exact thing. I'll run it. So here we have seen the legacy application where we changed the calculation. Well, we haven't changed the calculation algorithm yet, but we have taken all of the data that we need to do a calculation, stored it in an event, and then we're now publishing these events so that maybe other people can consume it. This is the new application. So before I forget to say, this is using the old Java 8. Is anybody still using Java 8? Some people are not using are using a newer or an older version. Oh, okay. It's not that legacy. It's using Java 8 and Spring Boot 1.5, if I remember correctly. And then the new innovative application is using Java 11 with Spring Boot 2. And it's actually super simple. You just have a consumer that will listen to this kind of Avro events, so that information, that schema, is shared between those two. That's the coupling that you still have in the events. And it will, if I run it, it should print out the content of the event. As with any new version of Java, there's more warnings in the beginning. That's good. So here you can see that the event was consumed. It's actually nothing really special about this. It's just a Java 8 application talking to a Java 11 application, Spring Boot 1 and Spring Boot 2 communicating together. For a calculation algorithm, maybe Java is not the best part, but it's probably the one I know best. So. What am I trying to do right now? I'll go back to the presentation. Okay, so if we look back at the quote I started the presentation with, the problem that we are actually trying to solve is the calculation, calculating the optimal rounds for mail delivery. And we have extracted that bounded context for the legacy application, and we can now use or investigate new tools to do the actual calculation, and we only focus on the business. We're not focusing on some kind of crazy hibernate model that is lying underneath and is lurking in the dark. We just can focus on what we're actually trying to do. Now, when you're moving functionality from one monolithic application to multiple microservices, you will introduce communication between your different applications. So for asynchronous, I like to use Avro. You can also use an Avro schema registry so that your consumer and your provider can use a central registry so that they can talk about the format of the events that will be sent in between. If you use synchronous communication, that will be the typical um, Swagger or Spring REST docs kind of communication that you can use. Thinking about APIs is not enough. You will need API guidelines. This is not a talk about API guidelines. There's a couple of interesting there as well. You need to make sure that all of the parties, all of the different services, that they can communicate together, that they have some kind of API guidelines, and that these are documented as well. Because if you're not documenting them, then you can't change them. Again, this is not a talk about API guidelines, but one thing that I would like to share is Postel's law. Is actually also known as the robustness principle. Was created by John Postel a very long time ago when he was writing the TCP specification. So it is be conservative in what you do and be liberal in what you accept from others. So if you're consuming an API and it has the response sends fields back to you that you're not interested in, don't use them. Then you don't have the dependency if ever something changes to these fields. And also accept everything that's incoming. So if you receive more optional parameters than you depict, that should be okay. This is also known actually as the tolerant reader pattern. So there's more names for the pattern than there's words in the code. Make sure that your API is documented. It's not just good enough. If you have API guidelines, your API should be documented as well. You can use Avro schemas, as I said earlier, or Swagger or Ham or whatever that you like. Now, what's very important, and that's something that I noticed when I was but the first time that I used Spring Boot 2, I was not able to deserialize the Avro event. And it's the old serialization problem all over, where newer versions tend to do something more different. If you remember serialization, if you don't define a serialization ID, then Java will guess. And if your Java version is the exact same version between two applications that consume a certain event, then the guess will be successful. If you use Java, and I was using it Java 5 and Java 6, they have a different kind of way of defining the serialization ID. It's the exact same thing with the well, it's a similar thing with the Avro events, where you need to tell Spring Boot 2 which kind of message converter that they need to use if you want to use Avro events. They changed it, but they have annotations that you can rely on the others again. So there will always be some kind of coupling, because otherwise applications are just not communicating. But here the coupling is in the events. So again, not in application code. The talk is called Innovation Without Asking Permission. Is this actually possible? And how would this be possible? So the first thing that I would like to say is continuous experimentation. You need to try to establish some kind of culture of continuous experimentation. And this is also something that very large companies do all the time. You try something small. If it's successful, you try to make it bigger. If it's not successful, then just throw it away. Since microservices are small or loosely coupled, it is possible to throw something away without using huge amount of time. Imagine trying to tell your business that you're going to throw away your legacy application. Then you probably will find a new employer very soon. Now, this is really an opportunity. It's the opportunity of data science. It's the opportunity of, for example, if you do feature toggles, then you can monitor what the users are receiving, and then you can monitor how happy the users are with their new feature. You saw the calculation algorithm was still placed in the newer calculator. Some users could use the new calculation algorithm, and then you can say, okay, is this what you want? Do you like the result? Is it fast enough? Is it too slow? Is it correct? And then older users can still use the older algorithm, and then you can combine the feedback that you get from your users. Same goes for traffic routing, where you can do the same thing as feature toggles, but on a network level, where you say, okay, my users in this part of the world, for example, they are used to dealing with new things. They're not very conservative, then they can use a new version. And maybe you also have a conservative user that say, okay, I don't want any change unless it has been tested by a lot of other people. So if you monitor this feedback from the users, you can really use a data-driven approach to evaluate your experiment. Okay. Distributed systems are hard. I assume that everybody who has worked with microservices is very well aware of the 8 fallacies of distributed computing. If you're not, I added a link to the end of the slides. But there's a lot of focus on everything that can go wrong on network and transport layers, reliability, etc. Now, if you're not asking permission, the fact that distributed systems are hard will become harder. You need to see this as an opportunity to introduce monitoring, introduce logging, and make this very visible. Nowadays we have Grafana dashboards, we have Prometheus, we have Micrometer, we have so many things that out of the box can provide you with a lot of dashboards. If you display these to your users, then they get more information than they were getting in the past. If in the large calculation algorithm, maybe sometimes it doesn't work and nobody knows why. Oh yeah, there's a change in the database and I just got a null pointer exception because. If you make this very visual, people say, oh, this failed. Why did this fail? We need to fix this. That's already an opportunity. Because then your business, your users will say, I know what's happening in my system. So then you're already ahead of trying to convince them to even sell them more experiments, explorations. If you have seen the first Iron Man movie, you see that Tony Stark builds the first Iron Man suit in a cave, and he's super happy because he only had one suit. And he only needs to maintain one suit. If you've seen the Iron Man 3 movie, he has so many suits, sometimes Tony Stark is not even in those suits. He needs to maintain all of them. That's the exact same thing that could go wrong with microservices. If you're using new technology, then it's not enough anymore to know one technology stack. You will need to know every technology that you're choosing, that you're working with. So think about bug fixing, about upgrades, about extending software, etc. So if you spend some time on a technology selection up front, you can mitigate a lot of these things. Or maybe you can say, okay, we're going to use R for the calculation algorithm, but first we're going to study it because we want to know, want to make sure that we can maintain it as well. So if you do a technology selection, your technology choice can be well-grounded, and you use technology for solution's sake, not just for technology's sake. There's no free lunch, as I said earlier, and also it's about responsibility. If you want to do something within a team, and if the team gives you the possibility to do that, and it's something that you've never done before, then you should be responsible for it as well. Then you should take ownership. This means documenting what you did. This means maybe being on call if it goes wrong in the beginning. It means coaching your team members to make sure, okay, this is how we're going to do, an example, the calculation algorithm. In large organizations, it's often very difficult because they know if you build a Java application that they can have very easy access to other people who also know Java. But it doesn't become a showstopper if you really say, if you take ownership, if you document, if you make sure that you know what you're doing. And again, this is also an opportunity. Your older Java version, it's not supported anymore. If there's security issues with it, then your customer has a problem. You need to use that and say that, okay, this is not supported, we need to do something. And if you have smaller microservices, then it's very easy to investigate time in that specific microservice and learn from it and iterate over what you're doing, and then maybe go to newer versions of, in this case, Java. And also, this is example, I think I gave it before, something that I've seen in a very large project some time ago. If you're using Hibernate 3 and you want to upgrade from Hibernate 3, again, don't use Hibernate 3, to Hibernate 4, those are not backwards compatible. If you do that upgrade, there's going to be a lot of sleepless nights because it just doesn't work. Technology can only change, the pace can only be as fast if you sometimes include breaking changes. And if the thing that's being broken is small, then it's also easy to fix. And then last but not least, these days technology does not run in isolation. We used to say Java runs everywhere, it runs on my machine. Then there was Docker, and we're saying, oh, well, just ship your machine, and then you're going to put your Docker in a Kubernetes, and then you try to run that on OpenShift, and it doesn't work anymore. This is very different from what we were doing in the past. In the past, we had very large enterprise application servers like WebLogic or Glassfish or WebSphere, and these things took care of that for you. They had load balancing, they had libraries available that you could use, and if you want to use something else, that's going to be a difficult one. So there's actually a lot of value in enterprise application servers, but there's also a reason that we're not using them anymore. Licensing, costs, difficulties to upgrade, etc. Now, one thing that you have, if you, for example, run in the public cloud, then you can use a lot of services that are available for you. Ideally, if you truly want to be a DevOps organization, you should go talk to your product owner and say, I'm going to need your credit card because we want to go to the cloud and see which kind of services that we can use. This is not very easy to achieve, I can tell you that. But if you gain experience, if you do experimentation, you can start convincing people of the benefits. As promised, a lot of sources. I specifically really encourage everybody to watch the Greg Young video. It's very poor quality, but it's worth still going to them. It's about the fallacies. The reason DDD projects fail. The source code of the demo is available as well, although it's not that super interesting, but you can look at it as well. And then there's also the continuous experimentation that I got from Chef. That's also very interesting to look at. I'll wait for Sergey to take a picture. The slides will be available on multiple locations as well. Thank you. If anybody has any questions, you can ask them now or maybe buy a beer at the bar or